Hello everyone. This is in continuation with various numerical problems in Poisson distribution. This is the next one, question number 36. On an average, one house in 1000 means 1 out of 1000 in a certain district has a fire during the year. So that means I can write it as probability of catching fire is 1 out of 1000. So I can call this as small p. Okay. If there are 2000 houses in that district, means the number of houses, I will call it as n, which is 2000. What is the probability that exactly 5 houses will have a fire during the given year, right? So here, if you look into the since n and p are available, we can always say x, which is how number of houses catching. Sorry, let me correct it. Number of houses catching fire. So now it is very clear that x is following a binomial distribution with parameters n and p. But if we look into this n, which is 200, is greater than 100. That is one thing. Now then n into p, if I multiply, then it is 2000 into 1 by 1000. That is working out to 2, and that is less than 10. That means we had seen earlier two different conditions. If any of the conditions satisfies, then we can approximate a binomial distribution to a Poisson distribution that we had seen. So this particular problem also we can approximate it to a Poisson distribution. So let us do that. So we can call lambda as n into p, since binomial distribution can be approximated to a Poisson distribution. Since these two things are satisfying, means n is larger than 100 and np is lesser than 10 on that basis, right? So now what is probability of a Poisson distribution? Probability mass function, it is e to the power of minus lambda to the power of x divided by x factorial. Here the question is asking us exactly 5 houses. That means we are interested in finding out what is probability of x taking the value 5. So that will be e to the power of minus. Here lambda we already calculated. It is n into p. N into p is 2. So lambda is 2. So e to the power of minus 2. 2 to the power of x. X is 5 divided by 5 factorial. In the question, we have been given the value of e to the power of minus 2 as 0.1353. So we can substitute that 0.1353. 2 to the power of 5 is 32 and 5 factorial is 120. Suppose if the question has not given you this e power minus 2 value, if you have a scientific calculator, you can directly use that e power x function, or you can even refer to the exponential tables to find out the value of e to the power of minus 2, right? So either way you can able to find out. Now what is this? If you calculate this, you will end up with an answer of 0.036. So that is the answer for this particular problem. Right. Let's move on to the next. The following table gives the number of days in a 100-day period. So if you look into number of days, it is 100-day period during which automobile accidents occur in a city. Fit a Poisson distribution to the data. Already we had seen in binomial distribution, fitting a particular distribution means finding the expected frequency. So if I want expected frequency, for a value x, which we will call it as EF suffix x, then I need to know what is the total frequency, that is capital N, multiplied by, I need to multiply that with a corresponding probability, which means we need to first find out the probabilities for different values. So here number of accidents are considered to be our values, which is x. Number of days is the occurrence or count, so we'll call that as a frequency. So from this I can calculate f into x. Why f into x? Because if I have to fit in a Poisson distribution, I need to know the value of lambda. We know lambda is mean, and the mean from a data can be calculated as summation fx by capital N, where capital N is sum of all the frequency that is available already. It is 100. So the denominator is 100. For numerator, we will calculate it here, f into x. 0 into 40 is 0. 1 into 35 is 35. This is 30. This is 18. And this is 16. So if we add all these figures, 35 plus 30, it is 65. 65 plus 34, it works out to 99. So this will be 99 by 100 or 0.9 is the lambda value or the mean value. So let's move on to the next slide to continue this. Yeah. So what do we have now? We have found out the lambda value. Let me write that probability function, or let me write n multiplied by probability of x is equal to x. We know n is 100. Probability function for a Poisson distribution is e power minus lambda. Lambda is 0.99. Then lambda power x. So 0.99 to the power of x divided by x factorial, right? So I will write that. Now what is this? 100 multiplied by e to the power of minus 0.99. What is the value for that? It is 0.3716. Again, this can be obtained from your scientific calculator, or you can refer to the tables available, exponential tables. 0.3716, right? And then 0.99 to the power of x by x factorial. So that can be simplified as, I can multiply 100 into this. So you will have 37.16 multiplied by 0.99 to the power of x divided by x factorial. This is our n into probability of x is equal to x. What is this actually? This is actually our expected frequency for a particular value x. Now, for the first one, if I have to calculate, I need to substitute x for 0. So 37.16, 0.99 power 0 will be 1. 0 factorial is also 1. These two figures will become 1. So ultimately we have 37.16. So that can be approximated to 37. Okay, because it is a frequency here, that is why approximating it. Here it is 0.99 to the power of 1 divided by 1 factorial. 1 factorial is 1. 0.99 to the power of 1 is 0.99 only. Let us multiply that. 0.99 into 37.16. That works out to 36.79, which again can be approximated to 37. Okay. Then next one is substituting x for 2. So we will have 0.99 square, okay, into 37.16, okay, divided by 2 factorial. 2 factorial is 2. So I will simply divide it by 2. You will have 18.21, which can be approximated to 18. Now substituting x for 3, 0.99 the cube into 37.16, and then divided by 3 factorial is 6. This we will have 6.0009. So I will round it up to 0001, which can be approximated to 6. Now the last one, 0.99 to the power of 4, 99 to the power of 4 square cube 4 into 37.16, okay, divided by 4 factorial is 24, so I will divide it by 24. It's approximately 1.5 that I will round it off to 2. So this total should lead to the same total frequency 8, 26, 26 plus 74. It works out to 100. So these are the expected frequencies. I think in the question they are asking us to fit only the uh, Poisson distribution. So already we have done it. We have found the expected frequency for each value of X. Means the number of accidents, number of zero accidents expected is 37. 37 days you may have no accidents. 37 days you may have only one accident. 18 days, these are all theoretical frequencies or expected frequencies. The whatever is given in the data may be a observed frequency, right? So this is your expected frequency. So in case if you find these contents of the videos to be useful, I request you to please like, share and subscribe to my channel. Thank you.